Hi, I'm Dana Edge, and I want to talk about some applications of quadratic equations. How about this one? The sum of two numbers is 36, and their product is 315. Find the numbers. Okay, we know that the sum means to add. So if we let the two numbers be x and y, and you don't have to use two variables for these, although it's a lot easier, but we're going to figure out how to get it down to one variable regardless. So the sum of x and y is 36, can be written as x plus y equals 36. Now, if x was 30, y would be 6. If x was 20, y would be 16. X and y have to add up to 36. We could solve this for either one of these by saying one of the letters will be the other letter minus 36. So one of the variables, one of the numbers, and the other number will add up to 36. And you know that x plus 36 minus x, the x's would cancel out, and this would have to add up to 36. So here's one number, here's the other number. So if the product of these two numbers is 315, we could write that as x times y is 315. Product means multiply. Or since we know that y is the same thing as 36 minus x, we can replace that and say that x times 36 minus x is going to be 315, and this gives us one equation with one variable. If we distribute over here, we get 36x minus x squared equals 315. If we put everything on one side, and I'm going to move it that way so the x squared will be positive, then I would add x squared to both sides. I would subtract 36 from both sides, and I would add 315 to both sides. Now, we can factor this, or we can use the quadratic formula. If we just want to go ahead and use the quadratic formula, because 315 is going to have a lot of factors. Then we got x equals the negative of, b is negative 36, plus or minus the square root of 36 squared, well, negative 36, but it doesn't matter, times 4 times 1 times 315, all over 2 times 1. So 36 plus or minus the square root of 36 squared is going to equal 1296. Minus 315 times 4 is 1260. Divided by 2. So 36 plus or minus the square root of 36 over 2 would be 36 plus or minus 6 over 2. Split this up into two problems. 36 plus 6 over 2 would be 42. over 2, which is 21. 36 minus 6 over 2 would be 30 over 2 is 15. And notice that (21) times 15 is equal to 315. And 21 plus 15 is 36. Check. Let's look at another one. A rectangle is 6 feet longer than it is wide. Here's our rectangle. The area is 280 square feet. This notation it means square feet, and it does say feet squared, which is another way of doing that. And it literally means feet by feet. A square foot is a box which is 1 foot long and 1 foot wide. So this is 1 square foot. So what are the length and width? Well, it's 6 feet longer than it is wide. So if we leave W as the width, then we can say that the length would be W plus 6. The area, of course, is length times width. So in this case, the area is 280. Do not put your units into an equation because it'll look like variables. Length is W plus 6 times W is going to give us 280 equals W squared plus 6W is a quadratic, so we want to put it equal to 0, so W squared plus 6W, we're going to subtract 280 from both sides. Now again, we can either factor this or use the quadratic formula. Just to kind of shorten things up, this should factor as 14 times 20. The product of 14 and 20 is 280. The difference, since this is a minus, the difference of 14 and 20 is 6. To make it a positive 6, I'm going to need a positive 20 and a negative 14, sorry. So W minus 14 is 0, or W plus 20 is 0. This is going to give us W equals 14, or W equals negative 20. Now, obviously, the width cannot be a negative 20, so that's an answer to this equation, but not to this real-life problem. So if the width is 14, now notice that that does mean that the length is going to be 14 plus 6, so the length is 20. We don't get the length by dropping the negative off of the other answer, even though that frequently comes out to be the same. You've got to get the length by using this condition right here that you've been given. So the width is 14 inches. And the length is 20 inches. The length is 6 inches longer than the width, and the area would be 14 times 20 would be 280. So let's look at this one. Falling objects will fall at the rate of h equals negative 16t squared plus h naught, where h naught, h sub 0 is read as h naught. H naught is the initial height. So if you're standing on top of a building and you drop a rock, the height from the ground to your hand is h naught. T is the number of seconds it's been falling. H is the current height at any given minute. So when t is 0, h is equal to h naught, which makes sense. That's the starting point. When t is 1, the height will be negative 16 times 1 squared, which is negative 16 plus h naught. So when t is 1, it will have dropped 16 feet from the original height. When t is 2, at the end of the second second, it will have fallen. T squared will be 4 times 16, it'd be a negative 64, so it will have dropped 64 feet from the original height. Suppose h naught is 384. How long will it take to hit the ground? Now you can't use the distance formula on these because distance assumes that your rate is constant. And when something is dropping through the air, it's actually accelerating the whole time, unless it falls so far that it reaches a point where the friction against the air is equal to the force that's pulling it down, then it will continue to accelerate the whole time. So most things keep accelerating. So we've got h equals negative 16 t squared plus 384. So it starts out 384 feet above the ground, straight down, nothing in the way. How long will it take to fall that 384 feet? Well, when it reaches the ground, the height above the ground is going to be 0. So h is going to be 0. So 0 is equal to negative 16t squared plus 384. Notice if I move this over, I would get 16t squared, equals, and that is an 8. 16t squared is equal to 384. So basically I want to know, this is the distance it's going based on the acceleration and the time, and I want to know when the distance that it travels will be 384 feet, because that's how far it has to go to reach the ground. I think this will divide by 16, which would make life a lot easier. 384 divided by 16 is 24. So if I divide both sides by 16, I'm going to get t squared equals 24. So t is going to be plus or minus the square root of 24, which would be plus or minus the square root of 4 times 6. So plus or minus the square root of 4 times square root of 6, or plus or minus 2 times square root of 6. Now this is fine, it's an exact answer. Number one, the negative's not going to make any sense. because time can't go backwards. This is not terribly useful when it comes to actually figuring out how long that is, because whose stopwatch counts in terms of square roots of 6? So if we get an approximate, this is our exact answer, and it depends on what they're asking for. The approximate, they're going to have to give you how many decimals to run it out to. But what we would do is get the square root of 6. So we hit 6 square root, depending on how your calculator does it, times 2 is going to be 4.898979. Depends on how many decimals they want to go out. Let's say they say 2 decimals. Then you look at the third one. This is an 8, so we want to make this one go up. But 9 can't go up. But the 89, notice, is going to go up to 90. So 4.90 or 4.9 is still going to be considered 2 decimal places. So 4.9, slightly under 5 seconds, is how long it would take to drop 384 feet. So these are a few examples of how you would use quadratic equations to model life. And they're pretty common ones, so I think you'll probably find these useful.